Hi everybody! Today I'm going to talk to you about the notes for section 8.2, which is for the homework in section 8.5 of the module, and it's solving systems using addition and multiplication. Very similar to the last video, and I'll keep it short with just 3 examples. The only difference is, the goal is to eliminate a variable by making opposites. So I'm going to put this down here because last time they just happened to be opposites and they eliminated very easy. So here we go. Our job is to eliminate, get rid of, I don't care which one it is, the x's or the y's. Okay, by making opposites. Opposites just mean they're the same thing, but one of them is a positive sign and one of them is a negative sign. Okay, so I guess that said, you can see these are almost opposites. The problem is they're samesies, right? They're both positive 2y. But I think we could think of a number to multiply one of those equations through to make it a negative 2y. So I'm going to go ahead and I'm going to leave this one as it is. 7x plus 2y equals 24. And then I'm going to go ahead and multiply this one through by a negative 1. Doing that will change the sign of all these. And now we have opposites. As soon as you have opposites, you're good to add. So this is where the multiplication comes in. You got to use multiplication to make an opposite before you can add and eliminate a variable. So I'm getting a negative x here and a negative 6 here and a glorious 0 there. We've eliminated y's, and that means that x equals 6. Remember, what we found is just the first half of our point of intersection. We still have to go back and find the y half. And you can do that by plugging it back into either of these original equations. I'm going to use the first one. 7 times whatever our x is plus 2 times the y we're trying to figure out is supposed to be equal to 24. And we got a 6 for our x. So 42 plus 2y equals 24. Okay, so I'm just taking a look at plugging those in. Okay, and when we go ahead and finish our math here, we're going to have to subtract 42. Oh boy, let's see, I think that's 18. And then divide by 2. And we've just found the second half of our point. Okay, let's do one more. Oops, sorry, 2 more. I have 2 more of these. Let's look at this one. You can pause me right now, and I'd like you to think about how we could what we could multiply one of these equations by to make opposites. I see that we almost have opposites here, so pause me and go ahead and get started. Come back when you're ready to check. I chose to multiply the top one by a negative 1. I could have multiplied the bottom one by a negative 1 also. It doesn't matter. Just don't multiply both by negative 1 or you'll have samesies again. So this one I don't want to change because now we have opposites. And we can go ahead and combine them. This makes 0. That was ultimately the goal, is to get rid of, eliminate one of the variables. This is negative 2x, and this is, oh wow, 0. Okay, 0 is a number. Some of you freak out when you see a 0. Don't worry about it. We got this. Then I have to divide both sides by negative 2. And 0 divided into 2 parts, that's just going to be 0, right? And what we just found was the first half, the x of our point of intersection. Sometimes you find the second half first, but not in this case for us. Okay. So let's go ahead and back to one of the original equations, and we'll go ahead and find our y. I'm just going to go to the second one because I messed up the first one with all these parentheses and stuff. So I'm going to do negative 4 times the x we found minus 14 times the y we really want to know. All right, this is 0, so I get negative 14y equals 28, so y equals negative 2. And that's the second half of our point. If we were to trouble ourselves to graph these, we would find that they intersect at the point 0, negative 2. All right, let's move on to the very last one. This one is slightly different because I don't, like the other two, I had almost opposites right off the bat. And this one, I don't have opposites right off the bat. So we have to do a little thinking. Now, let's see. I think, I don't think I can make a 5 easily into a negative 7 or, I guess I could use a higher number, but I'm looking at those x's really suspiciously, and I think I've got a number that I can multiply this by that will give me a positive 9x so that I'll have opposites. I'm going to multiply by negative 3. And what that's going to give me is a positive 9x, a negative 21y, and a positive 48 on the other side. Which means I don't want to change this one at all because now I've got those opposites I was hoping for. Okay. And we can just go ahead and add these on up. This makes 0. That was our goal, to get rid of a variable. We have minus 21 and positive 5, so I think we've got a minus 16y here. And then we're going to have 64 over here. And if we divide by negative 16, what you've got is the second half this time of your point of intersection. We've got the y half. Okay, so we can get to the y half of our point of intersection. And now you can go back to either of those first two original equations and you plug your y in. I'm just going to use the second one. Negative 9 times the x we want to know plus 5 times the y we just found should equal 16. And the y we just found was negative 4. And I'm going to go ahead and just do a little cleaning up and solve for x. I'm getting a negative 20 here. If I add 20 to both sides, I'm getting negative 9x. That's a 0. Equals 36. And if we divide by negative 9, I'm getting x equals negative 4. Oh, wow, look at that. The point negative 4 is where these would intersect. Okay, folks, we should be ready to work on that on our homework now, and I'll see you in class.